All right, we're live back here, engineering from home live stream. Welcome everyone. My name is Zach Denham. I'm here with Bantam Tools. I'm here. I'm here in my house. I work with Bantam Tools, and today I'm joined by Ed Kramer, longtime Bantam Tools user. What's up, Ed? Oh, I think maybe you're muted again, or at least I can't hear you. Um, all right, while we suss this out, one thing. So today we're going to do something a little bit different. We're going to do a project show and tell. Can everyone hear me? Can I get like a confirmation in the chat that people can actually hear me? Okay, cool. So today we're going to do a project show and tell. The last couple weeks we've been doing a more of, I would say, like a curated live stream series. So we spoke about supply chain, we spoke about teaching from home, we've spoken about uh, engineering from home. Uh, cool, thanks guys. I'm getting the confirmation now. We've last week we had this wonderful discussion about textiles and how the textiles supply chain has been shifting and sort of bleeding edge work that's being done in textiles to potentially help in COVID relief efforts. But after every live stream, everyone's like, I want to see everyone's bench. I want to see what people are working on. I want to do a show and tell. So today we're doing a show and tell. We've got an awesome group of people. Like I said, Ed is joining me from Texas. He's going to show off some work that he's got going on his bench. We have Andrew Kleindorf, a good friend of mine who's in San Francisco, who teaches electronics. We've got Eddie Serratos. Eddie, I've never met you. I'm so excited to see what you've got going on. Sophy Wong is back. Dom Riccobene will be back to show off work that's going on for him. We've got the DeLong Watch Company. I think I'm saying that right. Ben Light and Mohit Bhoite as well. So, and then the mechanics. Okay, so how this is going to work? There's like a request to speak hand button that is on the side that you can see in chat. And what will happen is we're going to go through this order. I have a set list, if you will, for us. So I'll go, Ed will go, and then Andrew, you're on third, and we'll just kind of people will hit that request to speak button, and then Amanda, who's on my team, who's behind the scenes, will pull you up and we'll bring you up on video, and you can show off your work. So I think let's do this like 2 to 3 minutes a person and see where we end up, so we can get through everybody. So the thing that I have on my desk here is this is an oldie but goodie. This is a little light sculpture that that some blinking LEDs. But the reason that I bring this up and I wanted to show off what this project is because this was like really the first time that I saw the power between Eagle and Fusion. And so this is it's a little LED sculpture. It's in DMX controlled system. There's LEDs on the top and bottom side of these little PCBs, and it's all weighted down. Ooh, and very precariously hung here for this live stream. It's all weighted down with these little copper pieces, and the data, power, and ground signals are all in this copper braiding. It's kind of like desoldering braid. But the thing is, so the plate at the top was milled on the Bantam. I actually just remilled this, and the thing that I love about this project is I needed a way to actually mount the sculpture to the ceiling. So milled out a little piece of birch on the Bantam mill. And then if you're an Eagle user, you're also a Fusion user probably. And so you can pull up your Eagle sketch in Fusion and very quickly get all the alignment holes sorted out. So it just took me a couple minutes to basically align the piece of birch with the little copper PCB. So yeah, this is my show and tell. There's a much larger version of this with like thousands of pixels that was made years ago. But all right, I'm going to pass the torch. Ed, do we have your audio working? I still can't hear you. Shoot. Can we get a thumbs up or thumbs down if people can hear Ed? And do Okay. No on Ed. Okay. Hey, Ed, I'm going to toggle yours. Okay, Ed has left the room. Ed's going to rejoin. Let's bring Andrew Kleindoff up. So, Andrew, if you're with us, can you hit the request to speak button and we can bring you all up on video? And actually, for everyone who wants to show off a project, can you all hit the request to speak button so that we can just start pulling people up? Okay, Andrew. Okay, Andrew, I saw you, but then I didn't see you. Hold on. Invite as presenter. Okay. Thanks, everyone. All right, Andrew, hit the turn the audio on and the video on button.
Audio, can you hear me?
We can hear you. And then we just need your video.
Video. Got it. Awesome. All right. Thanks, Zach. Yeah, so thanks for asking me to be part of this. Yeah, so I work with a lot of electronics and I teach students electronics. And so honestly, in the studio, I've been spending tons of time building boxes of electronics to send my students. So like you can see all these boxes with names on them. And down here, I've got even more. So I've been doing a lot of that, but I have been also for my own work making a lot of light up sculptures. And so I've been using Bantam Tools. So like here's one example. And so these are just small rechargeable. And I've been milling, like the bottom here is all walnut. So I've been milling and hand finishing those. And then this is a piece of cherry. And then I have a thin acrylic piece here in the middle with you got the switch and the little USB charging port. And then these are made to be super modular, easy to kind of like build and take apart. So you can see inside, they got the battery and the microcontroller and then just a NeoPixel ring. Yeah. And so I've been building these for a little while. I have a few, and I've kind of been following that theme of like a little bit of acrylic, a little bit of wood, and then like a 3D printed top that's usually about 1 millimeter thick that lights up. And they're all rechargeable. And this one's called Sweet Loaf. Yeah, this one's called Chonky. I'm realizing it looks a little coronavirus-y, which is not. I made it actually designed it before the coronavirus, but maybe it can keep it away. I can figure that part out. And then like here's just one more that I worked on. This one's got the charging cable on it, but yeah. So and then I've just been milling these pieces with the Bantam Tools mill. Just starting with kind of raw stock. Yeah.
So good. I have one quick question.
Mm-hmm.
All the wood is so clean and polished. It looks beautiful. What post processing are you doing? Much post processing on it?
I am not. Like, I mean, in fact, this one actually kept the tool paths. I don't know if you can see them just a little. Yeah, because they just looked so cool. But I mean, I'm hand sanding them and just like I started like as a very traditional shops person, and so I really still appreciate this sort of starting with the 150 grit and going down to the 300, then down to the 600, and then just putting like a polyurethane, multiple hand-coated polyurethane finish. So they start off very sort of machined, but then it's a lot of handwork in the end.
So good.
Yeah,
it's amazingly refined. And so just to recap, and before we move on to Sophie, so Andrew, you're teaching electronics in a high school setting, and so what you're describing is you're basically trying to keep the ship moving, and you're sending out electronics kits to all of your students right now.
That's exactly right, and it's actually gone pretty well. We were using particles, which I know Mohit may talk more about, but it's really cool because they're internet connected. Like I'm actually able to log into students' accounts and work them through problems remotely in a way that's been really kind of fun. And I think it's caused them to sort of realize like, what is it like to have to not have the teacher in front of you all the time and to try to figure out problems on your own. But yeah, I'm shipping out like 40 boxes this week of things so that we can finish out the semester with another kind of project. And it's been a ton of work, but it has some cool things. I'm happy the students can keep learning and we can do something remotely.
Andrew, thank you.
Yeah.
We need to get you on the show maybe in one of these upcoming weeks to talk about how you're teaching electronics remotely.
Cool.
Thanks so much for sharing.
Yeah. Thanks so much, Zach.
I'm going to hit the eject presenter button now.
Okay.
We'll bring up Sophie. Okay. Sophie.
Hi, Sophie.
Oh, you need to turn your audio on too.
Hey, can you hear me now, Zach?
Can you hear me now?
Yeah, and I can hear you too now, Ed.
Thanks.
Oh, great.
Hi, Sophie.
Hi, Ed. I really want to say hi to Ed because Ed, we've never met in person, but Ed has been helping me with when I have issues on my Bantam. We connected early on Instagram right after I received the machine. And Ed has been so helpful in helping me figure things out. I'm new to CNC, and it's sometimes really little things like, how much am I supposed to tighten this screw? Or why is this thing not doing what I think it should be doing? And Ed has been so helpful. So just want to say thank you and hello.
Oh, you're very welcome. And you've been turning out some amazing stuff. I think you got it down.
Oh, thanks. Well, every time I do something, I learn a little more. The last time I was here, I was showing this, which is my dodecahedron made out of milled PCBs. So each panel is a pentagon like this, and they've got 5 neopixels in series, and each one is basically exactly the same, and I just made them connect from one to the other so I could chain them like a regular neopixel strip.
Yep.
And it looks the same as it did last time, but I'll just turn it on and show you what I've been.
It's complete. I think the last time I saw this, it was still partially.
Oh, maybe it was still in pieces. Yeah, it's all been a blur. So right now, I'm gonna just pan this down. So right now it looks like this, and it's running just the demo code for a NeoPixel from the Adafruit NeoPixel Uber guide. But I'm going to be doing some custom code for it to make it look more like the prop that I'm building this for, which is, I'll show you a picture. It is going to be this prop here, which is a big glowing orb. I'm building this whole costume. And so this PCB dodecahedron is going to fit inside this giant orb. And I made a little small scale prototype. So this is basically what it'll look like, just this gold area with green behind it. And then obviously all the lights will be green, and they'll be doing some kind of glowing green pattern. So that's where this is going. And in the meantime, thanks. I can't believe I made this. This is the first time I've done milled PCBs, so I'm learning a lot. I've had to learn how to design my circuit so that I could mill it. I had to learn about trace widths, and I had to learn Eagle, which I'd never used before. And then I also am integrating it. I'm getting this crazy glow on my face now.
Yeah, I'm getting a purple glow. You're getting a yellow glow.
We all have like special lighting. But I'm also using Fusion to pre-visualize my finished prop. And so I wanted to make sure that my orb that I was building for the inside could fit through this hole. I'm trying to figure out how I'm going to prop it up in the center. And I think I'm going to do some 3D printing. I'll probably make a 3D printed tower to make this dodecahedron sit in the center. And I want that to all sort of mount into the bottom of this orb. And I'll have my microcontroller at the bottom. So I'm doing this kind of like all of this planning and engineering around this prop, and I'm kind of building it all in Fusion and then taking it from there. Like I built this dodecahedron in Fusion, which was also really hard, and then exported a face into Eagle so I could build my board on that. So I knew that this little board I was building was going to fit perfectly into my bigger prop. So It's all a whole bunch of learning all at once. And
Yeah.
meanwhile, I'm working on the actual costume, which is coming along.
This is what I was going to say. Is I had forgotten until we did the last live stream, the first one with you and Mohit, where you reminded me that your previous profession was as a costumist for the Seattle Orchestra, or right?
Yeah, Seattle Opera.
Opera,
So I
excuse me.
worked at
Yes,
I worked
that
in
would
the
make more
costume
sense.
shop. Right, yeah. Sometimes they need costumes. They need a lot of tuxedos at the orchestra. I used to work at the costume shop at the opera, and I actually didn't make costumes in the shop. I worked as I was more support for all the technicians in the shop. It's a union shop, so my role was specifically to do sourcing and research and experiments and some support work for the technicians, and I never got to build an opera costume. So I think that's why I'm so excited to be doing like these projects on my own now, because I learned so much just being around them and bringing projects in and sharing my personal work with the professional technicians there and learning from them and working alongside them. So, and by the way, I just want to mention a lot of the costumers that I worked with at Seattle Opera, they've been temporarily laid off right now because of COVID and there's no performances, but they're all making masks. They're making tons of masks and they're working so hard for, just to do whatever they can, putting their skills to work. And let me tell you, if you want to have a sewn mask that is going to help you on the front lines, if you're a healthcare worker, if it's made by a costume technician, it is going to be the most amazing mask. It is going to be sewn to spec. It is going to fit you. It's going to be comfortable. And they're just doing amazing work. So when this is all over, just support the arts.
Yes, you're here. Sophie, thank you so much.
Thank you for having me.
Yeah.
Thanks, Sophie.
Ed, do you want to, while we bring Ben up, do you want to share what you've got going on your bench?
So I got a couple of things. Been making face shields on the Neo based on the 3D printed design, but this kind of snaps together here. But it's a two-piece design that nests a little bit better. Like I can get more of these out of the sheet. So these are really, it took about a minute each to make on the new machine. I'm out of material now, so I just gave away my last batch. I think they end up going to like University of Nebraska, but I should have some more material in. And in between that time, Sophie, I'm also, you'll be proud of me, I'm working on an electronics project.
Oh, how cool.
Bantam Tools milled with a little engineering change
Nice.
on that rev of the board. Yeah, and I've got this too, which I'll be making an enclosure for a Raspberry Pi with touchscreen, temporary 3D printed enclosure, but it's going to get a proper aluminum case from the made on the Neo. I'm working on nothing beautiful, so it's all functional stuff here. I'm working on liquid sensing application based on capacitive sensing. I'm trying to put some sensors on the new machine to kind of look for low fluid levels on the coolant and stuff like that, just so I don't basically, so I get some notification, right, that I need to check some of the fluids on the machine if I run low on mid job. And then let's see, what else do I have? Oh yeah, so I was working on using Fusion's rotary toolpath to do some 4th axis work in Delrin. This is just a test piece, but it helped me develop 4-axis toolpaths. Yeah, that worked out really well. You can't really see, but the surface finish on this is like amazing.
It's Delrin?
Yeah, that's black Delrin. Just some scrap I had lying around, and I thought I saw something. This shape, it was a demo piece that Datron was running at Emo, so I kind of modeled up as close as I could get to it in Fusion, and then been using it for development. I'll do one in aluminum next once I get a little bit more time. I think that, the only other thing is I made my first stainless steel piece. It's kind of messy, but need to work on the finishing, but it's a square driver. Just like a little, bit for a
so much 4th axis work.
Yeah, I'm loving the 4th axis on that machine. So
that's really awesome.
Yeah, and then I have some Bantam some watch stuff to do later this week, or actually next week. So I should be showing that. If the client will let me, I'll be showing that work next week.
Cool.
That's
Awesome.
cool. Can I jump in really fast? I have something to add on to Ed.
Yes. Yeah.
Just because Ed showed the face shield, which I've been 3D printing these for Matter Hackers, and this is the plastic face shield portion that snaps on, and it cuts out of, you cut it out of 8.5 by 11 transparency sheet.
Okay.
So I designed to go on top of that, and this will work on the ones that you're making too, Ed. To go on top of that, I designed an extender portion for the forehead.
Okay.
So
cool.
This is what it looks like when you snap it on. It snaps onto the same holes. And this is the 6-hole version, but I made files for 3-hole as well. So it will work on the 3D Workstand model. It'll work on the Prusa model. It'll work on any of the ones that are using 3-hole or 6-hole configurations. And it just snaps on to the existing holes like this. And then these top tabs snap down and you get that visor dome like that.
Extra protection there.
Just a little extra protection.
Very sweet.
Yeah, we just spun up. My colleague Courtney is she's one of 2 people that are at our office. We've got someone shipping product out, and then she's there, and she's rocking the 4 MakerBot printers that we have, continuing to do the face shield design. So
that's awesome.
Just out of curiosity, how long does it take to print one of the headbands for like your style, Sophie? That looks
this
very similar.
thin one? Yeah, this takes about, on my machine, it takes about 2 hours, maybe less than 2 hours. It's super fast. Other people are printing it even faster, and I think on their website they've got some settings that they put out for specific printers. They can print them in like under an hour. Like, wow. It's super fast, and it's the way that they're printing it is all concentric lines. So the lines are, so there's no zigzagging along the arms. It's concentric lines the whole way around, so it has really good tension. It's not going to snap apart when you're opening and closing it like this. And it.
I'm sorry. Were you using PLA or what material, or ABS? Or?
I'm using PLA. I think they prefer, a lot of hospitals are preferring PETG because it seems to be easier for them to sanitize or something. Yeah. But PLA is acceptable as a substitute for a lot of hospitals. So that's what I'm printing for Matter Hackers.
Okay,
cool.
Yeah, I know it's not I don't know if it's a printable option, but like we were doing these in Delrin because they're, for the folks that are CNCing, I think Delrin's a pretty good choice. It's a little more expensive, but it can be autoclaved and pretty easy to sanitize.
Yeah, and it's not gonna. Is it?
Yeah, it's very strong. Yeah, it's very strong.
Oh yeah! Wow. Cool.
Sophie, thank you so much. We will eject you as presenter. The names of this thing it's just hilarious.
Bye, Sophie.
Bye, Sophie. Thank you so much. Mohit, I see you in here. Do you want to turn video on? Hey.
Can you hear me okay?
We can hear you okay.
So this time I just decided, to point the webcam down instead of towards me because it's very difficult to show tiny objects. By the way, Ed, congrats on your new CNC. That is a boost.
Thank you,
Mohit. So I have been working on these, back to old school beam-based circuits. These are tiny little solar-powered circuits called pummers, and what they do is they're nocturnal. So all day they will charge this little supercapacitor on the bottom through these high-efficiency solar cells, and in the evening, when there's no light, the LEDs will start pumping, which is like a burst of energy. And this is really difficult to capture because these solar cells happen to be actually very, very efficient and sensitive. So I won't be able to do this in light. But what I'm excited about is putting this on a stand, and just have it set on my desk pointing towards the window. And turns out I had a different version that I had made before, which is used a different kind of solar cells. These are used in calculators and like really vintage old solar powered electronics. But turns out the new ones, these are, I believe, monocrystalline versus amorphous silicon, and whatever that difference is, these are extremely efficient. They're able to churn out almost 16 milliamperes versus a few microamperes from this guy. So this will take a whole day to charge. This charges, I think, within an hour.
So good.
But yeah, I do want to put this on a walnut stand with a tiny brass rod sticking out and mill a small walnut bottom. The good thing is it's self-powered, so I don't have to run any wires to it. I feel like I want to make more.
Do you have a light sensor on there, or are you just monitoring the?
Oh, the circuit is clever enough that it uses the solar cells as a light sensor.
Oh, very cool.
And this is, again, very, very old school. This is like 1996 or 97 when these became popular. And that's how I got into electronics. It feels good to go back to the roots and design circuits where it all began for me. So Mark Tilden has been a huge influence, as I have said before.
That's what I was just going to ask you. Yeah, to name drop Mark Tilden for you. I loved digging into that after you mentioned that to me.
Definitely. And there's one more that I tried, but it's broken. So I might put new solar cells into it. So this, I got the solar cells from a surplus store, and they somehow got destroyed. You see the silver line over here. I don't, maybe overexposure to the sun, California, I don't know what happened to it. But I might replace this one, like solar cells on this one, with these tiny solar cells that I had gotten from DigiKey. These are made by a company in, I believe, Korea. I don't even know how to pronounce this name. IXYS, Axis. I don't know. But the funny thing is, these are literally circuit boards, PCBs, with like copper pads on them. So very easy to solder, moisture proof. IXYS. I have no idea. But easily available on DigiKey, and they come in different sizes. There's this one and this like really tiny one. And it's just a whole world of possibilities what you could, configure them and like create a pentagon, an octagon, an array, or like something like a international space station with like huge solar panels. So pretty excited to be using these new solar cells. And to bring this circuit to 2020, I made a small, I don't even know if I can, maybe. It was small, it's called, what is it? It's a solar charger, but it boosts the voltage from low voltage to high so it can properly charge and regulate the voltage. So this is more appropriate for like driving tiny radios. So I'm hoping to make a small, like a base station with radios and a bunch of sensors, all solar powered, that chirps, weather data. It's still on Earth, but the idea is derived from, like the Mars rover. Or so that's.
Is that a boost buck power supply?
Yeah, I'm blanking on the name. That it's solar harvester.
Interesting.
And so it's pretty efficient, so I might use that instead of an old school logic gate. So I mean, it's just too many projects, too little time.
I love seeing the photo of this sunbathing on the rocks.
Oh yeah,
that you posted last week.
Oh yeah. So it's nice to have access to a open beach here in it's China Beach, and you get the view of the Golden Gate bridge from there. So just sunbathing. I'm just planning on adding more to the collection over time. But
so inspiring. Mohit, amazing as always. Thank you so much.
Thank you.
Thanks.
Thank you.
Nice to meet you.
Same here. So, it was nice to see you in person, Ed. And I just put two and two together because your background has shown up so many times on my feed. We're just like a massive collection of CNC machines. You're just like a CNC hoarder.
Yes, I am.
I wish I get to be in your position someday. Just surround myself with CNC machines. I only have one. If I would show you, like, where is that? Oh, there's it.
Oh yeah.
Tiny one over there.
Oh, that one. Yeah.
All right then.
Awesome. Thank you, Mohit.
Thank you. There you are.
Good to see you. Stay well. Stay healthy.
You too. Wash your hands.
Yes. All right. I think we have Mark up next to show off some watch work. Mark, are you there? If you switch on video and audio. And Mark's team posted this really, really awesome work from the Dijon Watch Company, mailing out a watch case earlier this week, I believe.
Here we go.
There we go. Mark, we've got a close-up. Hey, how's it going? And then we just need to switch on audio right next to the in the upper left-hand corner.
One way.
There we go.
There we go.
Yep.
You guys hear me?
Yes,
Yeah, we can hear you. We can see you.
All right. I'm just hanging out in my basement here, trying to avoid my 3-year-old son upstairs going crazy. I'm calling from Halifax, Canada. We're all on lockdown here, so I've been home too much, but it's given me a lot more time to get at my project, which is nice. So I'm actually an athlete first, and a maker second. So I got I actually got the other machine back, I guess 1 Olympic cycle ago, back in 2016. And I got it because I travel so much, and it's nice and convenient to take around. But I forgot that I don't have any time to do anything because I'm training all the time. So it's been really nice right now just to have a little bit of a break. There's not a lot of training I can do, going for runs every day, but otherwise working on my watch project and hanging out with my son. So I've been working on the regular COVID-19 stuff. I made a little respirator here that I actually started making it with AeroPress filters, but couldn't breathe very well. So made a little bigger one. Whoop. There goes my phone. Sorry, guys. And then other COVID-related news, beard trimmer into hair trimmer. I don't know if you guys ever tried to trim your hair with a beard trimmer, but it's tricky. So that was my project. That was actually an Easter project. My latest one.
Model from you.
Yeah. I have a lot of people asking me to make clippers for them, and the answer is no right now because there's so many different models. But it'd be cool to make just a universal one that someone could hold and use on anything. But this is the other mill Bantam related project. I'm making this little women's watch. So I make watches. Most of them are bigger. These are my men's watches. That's the first one I came out with, the Mark 1. And then this one is my latest automatic. It's a little bit bigger. But the women have been requesting watches as well. And this is just a little brass one that I milled the other day. It turned out pretty well. It's my first time milling with brass, and it polishes up pretty well, which is pretty sweet.
And you had sort of a clever way to do the flip and do the fixturing for the second operation.
Yeah, I'm not a machinist, but I figured if you punch a hole all the way through and then you flip it, and you can put your tool back in that hole and figure out how much you have to offset it by. That's what I did, and it worked out pretty well. It's good that it's round too, so I don't have any angle issues. I can just kind of flip it and make sure that hole is in the center, and then you mill away. Whereas if it had arms on it, you'd have to make sure that those arms are positioned well too. It turned out really well. I was surprised actually. Maybe I'll make a little production run. This is sort of the milled portion of it without the rest of the guts, but I made my own watch dial too, which was pretty challenging.
Whoa.
I was talking to some watch people about a month ago, saying that I was going to take a stab at watch dial making, and cannabis is legal here, but he said, I don't think there's enough cannabis in Halifax to believe you right now. It's pretty tricky, but it's churning out pretty good results. I have these little dial blanks with a sunburst finish on them. It's like a really fine radial finish.
Cool.
And I've just been engraving those. I went through 2 1/64 inch bits yesterday though, because the thing wasn't perfectly level. I was trying to mill all the way through. Yeah, other than that, I have this is my soon-to-be masterpiece, the Derp Goat. I'm hoping to make that. So I sail on a team called the Goat.
Okay.
Along with paddling, and someone just drew this ugly sketch of a goat. We had no idea what it was, but it had an arrow saying goat. So I decided to turn that into like a real life thing, and I 3D printed it, and it's just kind of funny to see a real life thing. But ultimately, I want to get into casting and turn that thing into a bronze trophy, so that the goat crew can win the Goatish Moment Award every year and have something to bring home. So that's my next step. I'm gonna get into casting. I just ordered some machinable wax 3D printer filament. So I'm gonna be 3D printing that, finishing it, and then hopefully making a cast.
That's awesome. Yeah, the machinable wax is a lot of fun to work with. I mean, you're gonna be printing with it, but yeah, also milling with it is really neat.
Yeah, I figured too. Just printing I could print a little like square piece of stock too. Pop that in the mill too, and that would work as well. So it'd be good.
Yeah, not to plug our store too hard, but yeah, we actually carry little 3x3 squares of machinable wax, so you can make a negative for like a silicone mold.
Oh, okay, yeah, that'd be cool.
Yeah, it's fun to work with.
In Canada, it's always hard because we have to pay customs and stuff to get that over here.
You can find it. It's pretty ubiquitous. It's the purple stuff that you see everywhere.
Oh, okay, cool. Do you know many people that are casting with that, or is it just a silicone sort of simple, no 1300 degree oven type thing?
Mostly silicone stuff with the wax, and I'm not super familiar. Like, I really want to get into that, but haven't really tapped into it too much. Ed, what were you going to ask?
Jewelers making positives out of that wax, and then basically, for like silver casting, lost wax casting.
Right.
Yes, so that's what I'm planning to do. I'm going to attempt to do lost wax casting.
Cool.
We'll see how it works out. I don't know what I've gotten myself into.
So what materials are you working with other than brass for the case? Are you doing any steel on the?
No, I don't. So I've been watching some of your videos, and I've seen some people milling with steel, which is pretty intense. I haven't got there yet. I'm hoping to, but I've just been like, this is an aluminum version that I was trying to mill through, and then kind of got lost halfway through. Mm-hmm. But yeah, right now just aluminum and brass, and then when it comes down to production, I get a professional CNC shop to mill things out of 316 stainless.
Yeah, I don't think I'd try steel on the Bantam. I haven't done it.
Yeah.
But,
okay. Yeah.
Your work pieces look very similar to my stock that I like to use on the Bantam.
Yeah. I do like the adaptive roughing or whatever, but it always chooses to mill the whole thing off, and I'm being cheap with my time, so I just could put in a drill bit width outside of the stock or the piece itself.
Yeah. Nice.
That's been all right. Yeah.
Well, Mark, thank you so much. That's awesome. Good luck with the watches. They were beautiful. And again,
check goat.
And with the goat. Totally.
Yeah. The goat. Most importantly, the goat.
Goat casting.
Exactly. All right. Thanks, guys.
Awesome. All right.
Bye.
Cheers.
See ya.
Dom, I think you're in the chat with us. Hey.
How's that sound?
We can hear you and we can see you.
Great.
What's up? Good to see you again.
Nice to see you guys. Well, I haven't been working on that much yet. Everything's kind of been thrown out of whack, but I've been going through some old footage. I probably only use like 5% of the footage that I actually shoot in my projects. But I was going through some of the footage for my purple mattress project. Cool. Also just the files that I had to make for that. And I thought I'd share a little bit of that with everybody.
Awesome.
So if it's all right, I'll share my screen.
Yeah, go for it.
So first, I had made a project pitch for them when they first asked me to come up with something. So I'll show you that. It's kind of funny. I'm going to play it double speed just to save a little bit of time.
Okay. Are you already screen sharing now?
Nope.
Okay, cool.
Right now.
There we go.
All right. So this is my product pitch.
We don't have audio. It's the only thing. So you might have to give us the pitch while you're.
Okay. I'm going to turn my volume down. That's strange.
I think it's just a thing with the this screen sharing from here is that we don't
All right.
even get the
No problem.
get the audio.
So this is my original project pitch. They wanted the topography around Utah Lake, and right here is their locations, their old location, their new location, and they originally wanted me to do it out of wood, but then I thought it'd be kind of neat to use some of their material inside of the piece, because when you visit their factory or their office, there's always people like touching the grid, and I thought it'd be kind of neat to make it tactile. So I was going through a few options using their material or making it out of wood. This is good. That would be Paduk, Bloodwood, or Purple Heart were the options that I gave them. And then also an option that I gave them was to engrave the roadways. I think that's going to come up here in a second onto the piece, which ended up being a pretty cool idea. But and then I had to go over the benefits of using some of the wood, fitting their cushion in. If we wanted to fit the cushion in, it was going to have to shrink down a little bit. I explained this much better in the actual audio. So we'd have to shrink it down a little bit to fit their cushion in. And I'd explain when you use these exotic woods, they tend to oxidize over time and get darker. In between 10 or 2 or 10 years it takes, depending on how much exposure to UV light there is. But also I was kind of trying to push the high density urethane that I wanted to use, because it's kind of funny at the end. So the big challenge of this was embedding this really flexible rubber inside of this piece from the back, without having it fall out and still having the ability for visitors to manipulate it. And the original concept had this corner exposed, and I scrapped that and kind of zoomed out on the terrain more, so it was totally surrounded. But so yeah, these cushions are super springy, and they twist and they just go all over the place. So what I had to do was pretty much machine the tooling that would have been used to make that into the back of the piece, which was a really difficult operation. Luckily, I used really dense material. It was 100 pounds per cubic foot. And I just had to slot out all of these grids, just like their injection mold probably looks like. So that was really difficult to do with such hard material. And I had to use an 1/8 inch bit, and I just had to go little by little. I think I have some footage of that.
That's crazy.
Yeah, this is crazy.
So yeah,
Is it silicone or what's the material?
It's called MB5000. It's the tooling plank. It's used for nickel plating mandrels.
Oh, okay.
Really hard. It's as hard as a hard hat. So this is the back.
Wow. Oh my god,
and
the footage is so good.
And I thought I'd try to start with drilling out the intersections of the grid, but that ended up being not the best way to go about it, because when I did the slots, I wanted to ramp into the toolpath, but when I had those holes there, when I ramped, it kind of defeated the purpose of the ramp when it hit those holes, and then it crashed right into the side. So that wasn't the best strategy, but it worked all right. I just broke one tool doing that, and then I eased off of my feed rate a little bit.
What is the pillow material for?
That's a seat cushion.
It's a cushion. Okay.
Yeah, and they make mattresses, but they also make seat cushions. I really liked the seat cushion material. It's kind of transparent. And this is just some slider footage of those passes. And then these cushions come out of their molds. They really weren't able to share that much, but I was able to kind of reverse engineer it. They shrink about like 10% when they come out of the mold. So I had to account for that and increase the size of my grid in the back. So the whole thing was suspended into the piece. So it just kind of stretched in every direction. and that's reverse footage of no, this is reverse footage.
Okay.
Actually putting it in took like 10 minutes.
It's
Yeah,
so satisfying seeing you
a lot
pull
of
it out.
finagling, but yeah, so what that allowed to happen was, I pulled up pretty much with all my strength, and it stayed in there great because, the tolerances had to be for the grid. They had to slide in, but also stay there. So what I did for that is I actually used a 1 degree taper ball and mill to do that. So there's a slight draft that allowed the grid to slide in, but also tight enough to where it stayed in there.
Very cool.
So yeah.
Awesome.
Switch back to my let's see. There.
So is this have you shipped this? Is this
I did ship it. I've got a packing on my Instagram of the packaging video that I was pretty proud about. I got a pallet. We have a bunch of different size pallets here at the plant, so I got a pallet just the right size, and then I used the purple insulation foam from Home Depot, and I kind of built some packaging around that. Turned out really good.
Some on-brand packaging. Nice. Yeah. Dom, it's so good to see you. And,
yeah, nice to see you.
Yeah. Nice to meet you, Dom.
Likewise.
What's just before you go? What's on your plate next in terms of projects?
Next, well, I've been going through all that old footage, and I'll probably put together a few posts for that. That's actually what happened with my Mount Fuji video. When I did that project, I kind of just shot whatever for the story, and then I kind of left that for 4 months, and then I looked back at it and I realized, oh, this will make a great post. And then that ended up being the best post that I've ever posted. It got about 20 million views across all the platforms. So I'm going to try to mine some of my footage again and see what I can come up with. But also, the last time I was on, I went over my chocolate bar project.
Yeah.
And I've got I made a 3D printing video of that mold box.
Cool. That's awesome.
It's only like, this is the box being printed that I went over in Fusion 360 with everybody last time.
Yeah. And if you missed that, definitely check out the live stream landing page, the engineering landing page.
I'll show you. And so here's the box with a temporary chocolate bar in it, so I can pour silicone in this mold, and hopefully that'll work great.
Nice.
So yeah, that's coming up next.
Cool.
All right.
Dom, thank you.
Thanks for having me.
Yeah, definitely. If you're in chat and looking at this stuff and you want to see more, definitely check out Dom's Instagram. I think Amanda dropped it into chat already. So cool. All right. Stay safe.
Great. You as well.
All right. Later. Well, I think we have 2 more people who've been wanting to join, but we've been having some technical issues. Ben Light and Eddie Serratos, I know we've been trying to get them up on screen. I'm not sure if it's going to happen. We'll give them a couple more minutes to see if we can't work this out. Otherwise, we might just have to do this again next week and continue the project jam. Ed, favorite project so far?
On the new machine, probably the 4th axis, that Delrin piece, just because it was my first chance to ever use Fusion's rotary finishing toolpath.
Yeah.
I actually never used it on the Pocket and C because I think just the rotary axis is a little slow to get the benefit of that toolpath. But on the Neo, it's becoming my favorite finishing strategy. So what else? The doing the mask has been very, I feel like I was kind of feeling useless up until I got the idea from someone else on Instagram to start making them. So
yeah, I wish that we could actually fit it in the build volume on the PCB mill. It's even the 2-part design that you have. It's too big. Almost positive.
Yeah, I didn't even check it. I didn't think to check that, but yeah, it probably is. I think it's you might be able to make 1 half at a time, but that would be really slow.
Yeah.
I think the really fast way to make them seems to be laser. Like
Yeah.
the laser cutter guys are cranking out a ton of these things. But yeah, the CNC stuff, it can be pretty fast there too. I think 3D printers, like Sophie said, it takes like about 45 minutes to an hour, but they've got much bigger farms of machines, so they can make quite a few on the 3D printer. That additive process works pretty good too.
Yeah. Yeah, especially because you can actually start machining it out of Delrin or something slightly less porous than ABS. So, all right, let's see. Ben's going to try one last time here. Ben, I'm trying. I've accepted your. Okay, we've got Eddie coming up. I think he's joining on his phone. There's a video switch at the top, Eddie, and audio as well. Yeah, well, Ed, let me know if you realize that the build volume is actually if it's doable on the PCB mill.
Okay.
Let me know. I'd be curious to turn those out. So Eddie, there should be a blue button on the top left that's turn video on and turn audio on. There we go.
Okay.
We can see you. But we can't hear you yet.
Can you hear us, Ed?
Hey, Eddie, can you hear us? This is the first time we've tried this on this live stream. This bringing people up ad hoc like this. So,
Oh, you see me?
yeah, we see you.
Yes. Hello.
Can you guys hear me?
We can hear you though. I'm pretty sure if you're joining in your phone and you're watching elsewhere, can you hear us now, real time? Hello, hello.
Oh, perfect. Sorry about that. Yeah.
No problem. All right, take it away. What you got? What you working on?
Yeah, delay. Oh man.
Good technical challenge here.
Okay, so let me see here. What I have is usually I work on stomp boxes for guitars, and if anybody follows me on Instagram, I have like these really intricate designs that are engraved into the aluminum, and I got a bunch of those that I work on. On top of that, I mean, a lot of it is a lot of breadboarding that goes into that. I'm currently working on a PT2399 Echo delay, and it's not boxed up yet because I'm still trying to tweak it. And but
these are so beautiful.
What it sounds like, it's
ooh.
So anyway,
very cool.
At the moment, I'm working on a delay, so I'm trying to integrate that into guitar, but I also want to, do some synth stuff. So with that specific delay, sorry. Speaking of delay, I'm like watching it on two screens.
It's no problem. We can hear you, and I think that you'll get this message in like 30 seconds. But a huge fan of your work, and especially the design element that you're bringing to this. And yes, please, if you want to make a synth module, okay. I would love that.
Yeah.
Hey, Ed, are you anodizing at home, or are you sending those off to get done?
This is like a Middle East recording session.
Yeah. I got to wrap my head around it. I'm primarily a guitar guy, so I'm still learning. I'm sorry? What was that?
Do you anodize the enclosures at home, or are you sending those off to be anodized?
I think that we should let Ed say some last words, because this 30-second delay that we're having is a little bit difficult to have conversation with.
No, I don't anodize them. I actually buy them pre-painted.
Okay.
Yeah.
Eddie, I want to do this again with you, so maybe next week we'll try this again.
And then I paint them myself also. So sorry about the delay, guys.
No problem. Thank you so much. Ed, thank you for co-hosting here.
My pleasure.
This has been fun. Yeah, that was a trip doing trying to have a conversation with I would love to. Yeah, goalie saying, "Can we get Eddie back?" Would love to hear some music.
Yeah.
I think I would love to as well. And unfortunately, I think it's really difficult to do a live stream with the 30-second delay. Yes, delay. Just jumping into chat. I think we'll wrap this up. We're about an hour in now. Let's do this again next week. So the plan for next week was we actually 3 weeks ago donated 3 of our PCB mills to 3 different organizations that have been using them to prototype PPE. So an Ithaca generator in Ithaca, New York, Moonlighter Fab Lab in Miami, Florida, and then also Deep Local in Pittsburgh, and they're working on everything from DIY UVC sterilization to electronics for ventilators. Anyway, interesting stuff. And so the plan for next week would be that we would have the 3 of those orgs up sharing what they're working on, and maybe we can get a project jam in again after that. So thanks everyone for hanging and staying with us through the technical difficulties as we figure this out.
Thanks.
You got it. Thanks for joining us, Ed. And yeah, Godspeed, everyone. Enjoy your weekend. Stay safe.
Yeah. Wash your hands, right?
Wash your hands. Mill on, as Amanda says.